mechanical system. This experiment is performed on the simple mechanical resonance system, and this experiment reveals some properties of the mechanical system. In the background, our steel body is attached with a frame to a frame with the steel plates, and we can maybe I need stick for not for you. Okay, the body is attached with a spring. This one is diagram. It's not clear. This one is mass, and that one is the plate, and the spring constant of the plate is proportional to the Young modulus, and we can calculate from spring constant from here, and the mass of the body can calculate because our mass is like a cylinder. We can calculate from this expression, and velocity and acceleration. For the measurement for the velocity and acceleration, we use the accelerometer and the coil sensor, but we don't have a velocity sensor there. Then we just use the acceleration accelerometer. And for the model, this one is a simple mass spring damper system. This one is Hooke's law. We can calculate the force, and this one is for damping friction. And this one is the total force that move to mass with some displacement and produce the acceleration. So this one is our balance force on the mass. We can calculate from there, and this one is final our matrix form, differential equation in the matrix form, and this one is our output matrix C. We can calculate from velocity from here, displacement from here, and velocity from 0, 1. Finally, this one is our Simulink model. So everyone knows about ABCD model. This one is ABCD state space model, and we can calculate from the velocity from here, and then derivative of our velocity. We can calculate the mass, acceleration, and this one is just for displacement. I just put C matrix different, and this one is the result for the acceleration from the simulation, and this one is also acceleration, and this is velocity, and this one is the displacement. Actually, we need just acceleration for the verification. That's why I just use the acceleration on the next to the next slide. And this one is our experimental results. This one is acceleration. This one is just a print screen for our experiment. Measurements. I explained already that how to calculate the mass. So my mass is in kilogram. This one is my mass 1.53, and here is the spring constant that we calculate from the Young modulus. And that one is our main part to calculate the damping parameter C. So we just calculate damping parameter C from the damping factor, and this Cc is here for critical damping. We can find it from this relation to K into M under root K into M, and this one is the relationship from the natural frequency, undamped natural frequency, and the damped frequency. This one is the relationship between them. And I calculate the damping factor from this logarithmic discrement method, and this one is the final relationship for the calculation, the damping factor. Then I put this thing here and here, and I calculate the final value of C. C is equal to 0.15. For the verification, then when I put all the parameters C, K and everything, this one is the simulation graph and this one is from the experimental graph, this one. So I just calculate the frequency from the here and frequency from here, and that was the same results. Here is little bit different because this one is little bit don't, I just don't have a here a sample. So but this one is same results from the experiment and from the simulation. And our final result is 2.63 hertz from the experiment, from the simulation, and 2.7 hertz from the experiment. So that one is, and this one is the final result in the same plot. You can see. Thank you. And this one is look like same, and also the frequency is same.